recording this computer. All right, I'm recording. If you gotta hit me up in the chat if you're like, no, I don't want my name recorded on a YouTube video. Okay. All right, so here we're gonna do. We are on day 2 of this lesson. We're doing loans and regressions, right? This is example 2. So Claude wants to borrow $25,000 to purchase a car. All right, so after looking at his monthly budget, Claude realizes that all he can afford to pay per month is $300. $300 is the limit at what he can afford. He really wants his car, so he's going to willing to take out any loan for however long he can to be able to afford this car. He really wants it bad. As we all know, taking out a big long loan like this is going to hurt him in terms of the interest and finance charges long term, but he doesn't care. Claude's willing to pay it. The bank is offering him a 5.9% loan. What would need to be the length of his loan so that he can stay within his budget? And this is kind of where I wish I had left the monthly payment formula out for us to take a look at. But we're about to look at this formula here. This might look somewhat familiar. It's really the monthly payment formula in the inverse, right? And I'll explain more of that in a second. In order to solve a problem like this, we're going to need to solve for t as the time that was the exponent. It was the exponent in our monthly payment formula, if you'll recall. I almost hesitate to do this, but let me try. So I do want to. I feel like I do want to do this. So remember, our monthly payment formula was it was our rate divided by 12, right? What was it? No, it was p times the rate divided by 12 times, and the expression 1 plus the rate divided by 12 raised to the power of 12 times t, right? T is an exponent here, and then we had over here 1 minus the rate divided by 12 raised to the power of 12t, all right? So we want to, for this problem with Claude, we want to find out, we know the monthly payment. We know he only wants to pay $300. We want to find out what t would be. What would t be? How many years is he going to have to pay on a loan in order to make a $300 monthly payment work? Well, to solve this kind of problem, we're going to need to use logs because that's the way to solve for an exponential issue, all right? So let's see, can I get rid of, I'm going to clear all the drawing, and every time I do this, it stops sharing. I hate that. All right, sharing back, okay. So that's what we're going to do. We're going to solve for t. To solve this problem, it's going to be necessary for us to perform some algebraic. Remember, algebra is that manipulation of equations. So on the monthly loan payment formula, to find the length of the loan given the amount of the monthly payment, we're going to need to solve for this exponent t. To solve for an exponent, we're going to need to understand the concept, the idea of natural logarithms. All right. So examine the following equation. This is meaningless to you, right? Y equals e to the x power. E is like Euler's number. That's the natural logarithm, the magic of the natural logarithm. It's to find the value of x when a given particular y, use the following algebraic transformation. X equals the natural log of y. This is read as x equals the natural logarithm of y, or when e is raised to the power x, raised to the exponent of x, the resulting value is y. If all of that is gibberish to you, that's okay. That's okay. Calm down. We're basically going to show you something that you're going to put it in your calculator, and we're just going to call it math magic if you don't want to dig any further. If you just want to trust me and believe me that this works, then all you need to know is that E is math magic, and it's Euler's number, and it's about logarithms, and it helps you solve for exponential problems, all right? So before the use of calculators, people used a logarithm table to determine exponent values. Now, graphing calculators have the natural logarithm key, ln. That's found right here. All right. If you don't have one of these great TI-84 emulators on your Chromebook, let us know in the chat, and we will direct you to some instructions and help on how to get one of these on your Chromebook. It's really easy. You go through Rock Connect. Rock Connect, there's a little calculator button. Click on that. Log into Rock Connect under Google. Click on the calculator button, and you'll have this on your Chromebook. All right. So if we wanted to find out, for instance, 130 equals e to the x power, we can press ln. Oop, my calculator died. There it goes. ln is the natural logarithm of 130. What is the natural logarithm of 130? Oh, look at that. It's 4.8675, yada, yada, approximately 4.9 if we round to the nearest tenth. All right, so we can just find the natural log of any number using our calculator. It's pretty easy. We're now going to use natural logarithms to solve for an exponent in the monthly payment formula by following this right here, the loan length formula. All right. I'm only doing this because a lot of students, almost half of you, said, I feel pretty good about this monthly payment formula thing. I was going to skip this whole piece, but then so many of you felt comfortable with the net monthly payment formula. I was like, maybe some of you can challenge this. This topic right here, this is not an Algebra 2 topic. This is like a calculus topic, all right? So you are you're dipping your toes into some advanced mathematics here, even if you don't necessarily understand all that's going on. That's okay. Believe I'm gonna show you a secret, easier way of doing this in a second. But first, we got to do it the hard way. All right. So here's how it goes. Claude, he wants a monthly payment of his monthly payment. He wants it to be $300. So we're going to need to stick 300 every time we see this capital M here in this formula. So here and here, we got to stick 300 in this formula. All right. P is the principal. The principal is how much is being borrowed. So we got to stick $25,000 in for P every time we see P in this formula. R is the interest rate, right? We got to stick, what was it, 5.9%, but it expresses a decimal. So we got to express 0.059 every time we see R, and that shows up twice. Pardon me, I had a cough. And then T is going to be the number of years. If we just stick this in here, the calculator will do all the calculations for us. So here's how it goes. All right. Are you ready? Anybody excited? All right, so here I go. I'm going to find out how long it's going to take for Claude to take out a loan of repayment in order to pay this off. So it's going to be the natural log of 300 divided by 25,000. 300 is his monthly payment that he wants to pay. 25,000 is the principal that he wants to borrow. I'm closing the parentheses just like it says. I'm going to do minus another parentheses, the natural log, pressing this LN button, right? 300 divided by 25,000 again. The 300 is the monthly payment that Claude is willing to pay. 25,000 is the amount that he wants to borrow, minus the rates divided by 12. That's 0.059 divided by 12 for 12 months every year. Close the parenthesis again, just like I've got two parentheses here. Oh, shoot. All right, I'm going to press enter right now because I did the numerator. All right, so there's the numerator. Last class, I showed them a different way. I'm going to show you that different way in a minute. But first, we're going to do it this way. We'll do the numerator first, then the denominator. All right. Yes, that's how I'll do it. Okay, so now I'm going to do the denominator, just this bottom part. All right, 12 times the natural log of, all right, 1 plus the rate divided by 12, the rate divided by 12, closing that parentheses, and I press enter. And now all I got to do is divide the numerator by the denominator. Ready? There's my numerator. I pressed up until I got to the numerator. I press an enter to put it in there. I press the divide because that's what a fraction does. It divides. And then I'm going to go up to the denominator, press enter, plug that in. I'll press enter to calculate, crossing my fingers. Boop. There it is, right? T equals 8.96. T equals actually 8.95689. Well, but if we round to the nearest hundredth, it's going to be approximately 9. We're going to basically say, for all intents and purposes, Claude is going to need to take up this loan for 9 years for this car. I do not advise you to take out a 9-year loan on a car. That's a bad idea. Cars usually break down after 9 years. You're still making payments on a car 9 years after you bought it. That's a financially unwise decision, but it can be done, and this is how Claude can do it. All right, let me show it to you again. All right, let me show it to you again with Jamie here. So here's Jamie. Jamie would like to buy a car for $20,000. After looking at Jamie's monthly payment or monthly budget, she realized that she would like to keep the monthly payment to $350 a month. The bank is offering Jamie a 6% APR. What would be the length of loan would have to be so that she can stay within her budget? All right, so I'm going to show it to you how Mr. K showed us that one time with the N over D this time, just to keep everything kind of similar. So I'm going to press this green alpha button, and then I'm going to press the Y equals button. This gives me this menu right here. I want this N over D selection. That's numerator over denominator. That'll give me this right here when I press enter. All right, this way I can keep it very similar to what it looks like over here. So I'm going to keep the same idea. I'm going to press the natural log, take the natural log of, now it's 350. That's the monthly payment. 350 divided by 20,000, right? divided by 20,000, that's the principal. So 350 divided by 20,000. Right, okay, I did that part. Now I'm going to do minus the natural log of, oh wait, they wanted me to do a parentheses in there. So let me add a parentheses. Let me put a natural log in there. Okay, now I got it. Now I'm going to do monthly payment divided by principal. Monthly payment is 300. The principal is 20,000. There's the principal. Okay, minus r divided by 12. It's 6% interest rate. That's 0.06 divided by 12. Divided by 12. There we go. Closing the parentheses. Closing the parentheses yet again. And now I'm done with the top. I'm going to the denominator. All right, here's the denominator. It's going to be 12 times the natural log. 12 times natural log. Okay. 1 plus rate divided by 12. The rate's 0.06 divided by 12. Why 12? Because there's 12 months in a year. Okay, I am done. I'm going to cross my fingers and hope for the best. If I was careful, I should get a reasonable answer here. All right, it's telling me it's 9.35. That wasn't the answer I expected, but it's pretty reasonable. All right, I'm going to put that down. 9.35. Did it tell me to round to the nearest anything? No, it didn't. So I'm going to have to call this probably. I might have to call this 9.35 is really close to a third, right? 0.333. So I'm going to call this 9 1/3 years. So you can do 9.35, or you could even call it, let's see, someone sent me something in the chat. I could call it 9 and 4 months, 9 years and 4 months. You could also do that, 9 years, 4 months. 9, that's not what I wanted. 9 years and 4 months. And there'll be a little extra payment at the end of this thing, or something like that. Someone sent me something in the chat. What do they want? 5-minute warning. Oh, thank you. Okay. For those, how are we feeling at this point? Could someone just tell me in the chat how you're feeling? You love it? Do you hate it? Are you overwhelmed? One student last period said that he felt just content. That's okay. Another student said, no thanks. No thanks, Mr. Solt. How do we feel? You want to come on mic? Tell me in person? Tell me in the chat? Do I have to do this in participants? How about this? Give me a yes in participants. Yeah. Okay, fair enough. Give me a yes in participants if you're generally feeling okay with this, and give me a no for I'm not feeling so hot. Just want to test the temperature of the room here. I'm about to show you the easy way. So I want to know how you feel about the hard way. Okay. We got a and I got a kinda. And I have a thumbs up. Okay, that's Mr. K. You don't count, Mr. K. All right. All right. For those of you who are kind of feeling okay, you can absolutely, I don't want to take this away from you, because this is one of those great things when you're at a family gathering. Someone says, so what are you learning in school? You tell them, oh yeah, we're learning how to solve for exponents using natural logarithms as the inverse of exponential functions. That sounds really impressive, right? You can really impress people. Well, yeah, in math, we're learning the beginnings of a little bit of calculus, just a little bit of calculus, You could, it sounds pretty cool. It sounds pretty cool that you're using natural logarithms. It's impressive. Here's the easier way. Remember this apps button? Remember that finance app? I press the apps button. I'm going to press enter. And this TVM solver. Well, guess what? This TVM solver can solve this for us. Watch how this works here. I don't know. Put in 0. If I put in 6% for interest, if I put in 20,000 for present value for how much is being borrowed, and if I put in the negative of the monthly payment that I want, like she wants 350, so if I put negative 350 here, and if the payments per year and the compounded yearly is 12, if these two things are set at 12, if I go back up to n, and if I do that thing where I have this thing solve it, alpha, enter, right? It says solve in green, alpha, solve. It'll tell me it takes 67.46 months to pay this off. 67.46 months. Well, I can convert that to years pretty easy. 67.46 divided by 12, it'll tell me how many years, right? Oh, I got a different number. I goofed something up in that first calculation. So I will have to go back and see what I goofed up. But this is what I got actually. I know this is right because that's what I expected. 5.62. If I had a lot more time, I would go back into some error analysis and try to figure out what did Mr. Salt do wrong in this problem here. Oh, I see a problem already. I put no one kept me honest. No one was watching what I was doing. I had no backup, and I put 300 in here. Right, that has to be 350 because that's the payment we want on this one. Did I goof anything else up? Everything else looks good. Look at that. I fixed that one little problem, and I get the answer I got from the TVM solver. Okay, so here's the deal. There's one more question for you to solve. You can, if you feel like you want to challenge yourself, by all means, use the lone length formula. Use natural logarithms to solve for an exponent. Do the impressive thing. If you feel like you don't want to do it that way, go ahead, go into finance, go to the TVM solver, and then solve this thing. The difference is a $400 monthly payment here. All you got to do is to make that negative 400. Thank you. Yeah, I know it was stuck in my mind. Exactly. Put that in for 400 and this will solve it for you, right? If you put a negative 400 in here, it will solve it for you. If I was to go up here and press green and enter, we would get an answer. It would solve it for us, but I'm going to let you do that. Your choice, however you want to do it. Go for it. If you are curious about natural logarithms, if you want to stretch your brain and learn some cool mathematics and some more calculus, click on this video here. He'll explain more and go into natural logarithms, and you'll understand what natural logs are more than just Mr. Soltz. It's magic. It's mathematical magic. All right. That's the best I got for you in the time that we're going to do. This is probably as hard as it's going to get, folks. If you can handle this, there's, everything else is easy. This is me trying to challenge you, push the envelope a little bit, because you guys felt comfortable with that monthly payment formula. And I was like, I think you guys got it in you to tackle something like this. I don't think we need to be afraid of natural logs as long as you just, if you, all it is sticking it in the calculator, really. So that's what we got. That's what we got here. Finish this last one up, answer any feedback, and then submit. And then that is, that's today. Okay. Remember to click submit to save your work on these Google Forms. That's very important. And any questions? You need anything from us? Class is over.
Oh, that's it.
How do you put it in?
Great
Someone
job.
asked, how do I put it in? Yeah, have a good weekend if you need to go. For those of you who wants to know how they put it in, okay, I'll show that to you again on the calculator. Go to press apps on your calculator. You want the financial apps, press enter. You want the TVM solver, press enter. The first thing you're going to want to do is make sure this P over Y and C over Y equals 12, right? That says compounded 12 times yearly, otherwise 12 times a month, and with 12 payments yearly. That's 12 payments per month, all right? Then you need to go make sure the interest rate is 6. Make sure the present value is 20,000, and then make sure the PMT is negative 400. All right, once you have that solved, once you have that, go over to N and press alpha, enter. Alpha, enter, and this thing will solve. This thing will solve for this. Okay, Mr. K. This thing will solve this problem for you. All right, that last one. So that's how that's done. All right, and of course, I recorded the session, so if you can't remember, you can always watch the video. Okay. Any other questions? All right, good. Take care, everybody. Enjoy your weekend.